What is nuclear chemistry? Nuclear chemistry is the study of the physical and chemical properties of elements which are influenced by changes in the structure of the atomic nucleus. It also deals with the energy released from nuclear reaction and its uses. It is also termed as radiochemistry, which includes the study of the formation of the elements in the universe, the design of radioactive drugs for diagnostic, medicine, and many other applications. Nuclear reactions are processes in which one or more nuclides are produced from the collision between two atomic nuclei or one atomic nucleus and a subatomic particle. The nuclides produced from nuclear reaction are different from the reacting nuclei. Two notable types of nuclear reaction are nuclear fission reaction and nuclear fusion reactions. The former involves the absorption of neutron or the other relative light particles by a heavy nucleus, which causes it to split into two or more lighter nuclei. Nuclear fission reactions are the processes in which two relative light nuclei combine via collisions to afford a single heavier nucleus. Nuclear fission refers to splitting of an atomic nucleus into two or lighter nuclei. This process can occur through a nuclear reaction or through radioactive decay. Nuclear fission reacting often releases a large amount of energy, which is accompanied by the emission of neutron and gamma rays, photons holding huge amount of energy enough to knock an electron out of atoms. Nuclear fission reaction. Nuclear fission was first discovered by German chemists Otto Hahn and Fritz Strassmann in the year 1938. The energy produced from fission reaction is converted into electricity in nuclear power plants. This is done by using the heat produced from the nuclear reaction convert water into steam. The steam is used to rotate turbines in order to generate electricity. In nuclear fission reaction, at least two atomic nuclei combine fuse into a single nucleus. Subatomic particles such as neutron or photon are also formed as products in this nuclear reaction.
I am Jericho Ibanes and my part is radioactivity. Radioactivity is a phenomenon of radioactivity is a spontaneous breakdown of energetical unstable fluid into more stable liquid. A little amount of mass is transferred to energy during the exergent, statistically predictable first order process is called radioactive decay. Radioactive decay is an inversion of energy in the form of ionizing radiation. Ionizing radiation can affect the atoms in a living thing. So it is supposes health risk by damaging tissue, organ, and DNA in genes. Ionizing radiation that is emitted can include an alpha particles.
Beta decay. Beta decay is the emission of negatively charged stream of B particles from the nucleus. So there are two types of beta decay. They are called negatron emission and positron emission. Neutron emission is the emission of negatively charged beta particles, and the positron emission is the emission of positively charged beta particles. So let me give you an example of beta decay. Here in the example, we have the element xenon with the 118 atomic mass and 54 atomic number. So after its beta decay, what will happen to it? What's the new element? So here we have the electrons. As we know, electrons have almost tangible mass, so the atomic mass will stay the same. That is 118. But in the case of atomic number, we will add +1, which is 55. So what element has the 118 atomic mass and 55 atomic number? That element is cesium. Cesium, 118 atomic mass and the 55 atomic number.
Synthesis of new elements. From terrestrial rocks and minerals, scientists have been looking for traces of unknown substances. In the process, chemical elements were discovered. But they stopped looking for unknown substances and instead they began synthesizing new elements in laboratories so that they could discover and achieve some new things. Rate of radioactive decay. The rate of decay is often referred to as the activity of the isotope and is often measured in curies. 1 curies equals to 3.700 times 1010 atoms that decay per second. Knowing the amount of radioisotope and the activity of the sample. Radiocarbon dating. It uses the decay of the radioactive isotope of carbon C14 to measure time and date objects containing carbon-bearing materials. With a half-life of 5,700 positive-negative 30 years. C14 is a useful tool for determining the age of a specimen that formed way back time. And just like in the example, if neutron collided with nitrogen-14, it could produce an atom of carbon-14 and proton to dioxide and transported to the lower atmosphere. And photosynthesis take in carbon-14 in a ratio similar to the atmosphere C14.